Hi there, I'm Kevin Benedict, Senior Vice President of Solution Strategy here at regalix. I want to thank all of you out there for joining us today. This is a very special edition. Why? Because it's the second we've done today. I was with Rob Tiffany in person, the guru of Internet of Things, and my audio did not record. So I have a wonderful video I can watch over and over, Rob, but there's no sound. Number one, I want to just talk about the Internet of Things. You have served in a leadership position as a thought leader around the Internet of Things for a long time. You've been responsible for building entire platforms and products, and you're freshly out on your own, starting a brand new company called Enterprise Internet of Things, so Enterprise IoT. That's so exciting, Rob.
It's really exciting. You know, I have to hold back from saying super exciting because people say that too much. I'm really thrilled about it. It's great to have a passion for something and a lot of knowledge about the space and be able to make it happen. And so I'm going after it. We're going to step up to the plate and see what happens here. Okay, so this just begs the question. You've seen everything out there. You've been in front of all the analysts. You've built products that were in the right top side of the Magic Quadrant. You've been there. You know what's out there. Yet in 2018, in September of 2018, you think there's still room for building a platform and launching it and solving a bunch of problems. Talk to us about why now and why you think there's an opportunity. Sure, absolutely. I guess even though IoT is old and M2M and SCADA and all that stuff's been around for a long time, new things pop up every year. And I'd say it's a combination of probably two sides of the same coin. There's new innovations to investigate, to include, and there's blockers to adoption. Since if you go back several years when McKinsey told everybody it was going to be an $11 trillion space, it was a gold rush, right? And every company is racing, to their local VC to get a term sheet. But it hasn't worked out like we hoped. So I'll talk about both sides of that. What's not working out and what's new and interesting. What's not working out is customers are finding it too hard to implement, to deploy. IT departments can't make heads or tails of it. There's so many pieces of IoT, right? So you've got devices, the things, the machines, you've got microcontrollers. You're forcing people to try to learn how to write C code again on the little tiny things, and they're like, woo! You've got communications networks of all kinds. You have normal cellular, you've got Wi-Fi, you've got Bluetooth, Zigbee, Z-Wave, LoRaWAN, Sigfox. So there's a lot to know there. You've got these platforms that are kind of in the middle. They're like middleware that we've all done for a long time, and they're connecting things, and they're moving data around, they're storing data, they're managing it. They're connecting it to analytics of different types, simple things, advanced things, Hadoop, big data, machine learning, Python, R, whatever, you name it. Visualization. So I just rattled off a whole bunch of stuff there. And the idea that a customer and being able to take this product and into their enterprise, it's a tall order. So complication, people don't have the right skill set to do it. Customers, frankly, also are sometimes dubious about the payoff. Okay. What's the ROI? So there's all these headwinds. Security, we keep seeing these hack attacks, right? And so when people go, wow, there's so much promise and IoT is going to change the world. Oh, but by the way, you're also creating the largest attack surface in the history of computing. So, we got to balance that stuff out, right? So what's the answer to that, Rob? What can you bring to the table that will simplify the whole thing? The answer is, is obviously you need to have an open mind and not, be all into your stuff and think, you got to take all that stuff in and say, how do I radically simplify all this kind of stuff from end to end? It's got to be approachable. It's got to be easy for people to understand. so I have a mantra around simplicity, ease of use, kind of the Forrest Gump thing. And, it's got to work for everyone. I'm into using pervasive, widely used open technologies that everyone understands, not the fringe things, not the obscure ones that might be better. But, I think there's plenty of stuff out there that's good enough that all kinds of companies, all kinds of enterprises, organizations, governments can understand. So I'll always be erring on the side of simplicity. You won't go to my company's website and just see, thousands of pages of documentation of code that you've got to write to make this work. I always freak out when I see that because that scares people off. Security is such a big thing. There's going to be security to every tier of the infrastructure. Also, let me give you another headwind. We are scaring customers. Customers keep hearing two things in the sentence. They hear IoT, AI, and they go, oh, I got to have AI to get any value out of this IoT stuff. And I'm like, tell me how many people that know anything about real AI. I'm not talking the AI that people are fast and loose with, but the really hard stuff. Most of them don't. Even when we were just doing machine learning talk all that time, there's just data scientists growing on trees everywhere, right? And, all these algorithms. So my approach to this is people are conflating value from IoT with combining it with AI or deep learning or something like that. That couldn't be further from the truth. My message will always be, you are absolutely going to get value and incremental return on investment just by the simple stuff, just connecting your things. There's so many use cases where just remotely knowing what's going on adds value. So connecting your things, simple analytics, integrating stuff into that system. And I'm going to spend a lot of time on these use cases. Some will be cross-industry, and then going deep on these verticals to show folks that, hey, it doesn't have to be hard. I can make it secure, and I can get bang for my buck really quick. Most customers, they sure would love an ROI in the first year.
Oh,
they're
yeah.
just not seeing it, just absolutely not seeing it.
You said something earlier today in round one of our interview, Rob. You just said, there's so many people that have to drive out to collect data. And if they can just have that data brought back to them instead of having to send a human out, that's a huge value by itself.
Right. How
And
simple is that?
number two, you can build basic analytics with alert systems that say, if the data comes in and it's not supposed to be the reading that we received, alert me. So that's a number two kind of benefit. And then you can build the AI and machine learning on top of that basic environment. But there's a great deal of value just from the basics.
Yeah. And so you're always going to hear me just hitting hard on the basics. If you turn that dial from, okay, I have no value, I'm at zero, and you start going to when do I get 10? And also, people talk about opportunity or changing the world and all that stuff, and that's great, but let's cut right to the chase. It's all about money. That's really all this is about with customers. Is this going to save me money, or is this going to make me more money?
Right.
That's it. Everything else is just conversation. So I'm all about showing you, and what you will find is you'll get maybe that first 10 or 20% just getting connected, just getting real-time data, just not having human error and mistakes. Then you start getting more with just simple analytics, kind of like you're talking about, which is nothing new. People have been doing alerting and stuff like that for a long time. You're going to find that you're going to get a lot of your bang for your buck and cost reductions really soon from the simple stuff. And that's my message.
Wow.
When you start putting in deep learning and AI and all that stuff, which good luck finding those folks and knowing how to do it, it starts to get more incremental in the savings or the value. And so it's like, you know what? I'll leave that to later on. Let's take care of big, giant bang for the buck, save money, make more money, when you can change business models, and keep it simple for people. Don't go with this esoteric stuff. Speak the language people understand,
Yeah. So Rob, it's hard for me to believe, but there might be somebody out there listening or watching this video here that has not known about you before. It just blows my mind if that was actually the fact. But if they haven't heard of Rob Tiffany, Rob, talk to us about your background and what makes you the expert in Internet of Things platforms.
It's because I'm so old. It's because we've had a lot of rodeos, right? I've done this for a long time. Gosh, if I go back to the 90s, get out of the military of the submarines, and my first job is a startup that was taking dumb vending machines and bringing them to life with something that was like the Internet of Things. We were doing all that. We were putting controllers into machines. We're doing wireless, and it was so expensive. You had to pay by the byte. And we built all the same stuff and added value. And it was really hard back then. In comparison, what we're doing is child's play. It's so easy, or at least it's easy in my mind. So all those years of doing it, I did lots of startups through the 90s, through the dot-com era, like many people did. Yeah, good times. And the last startup I did before I joined Microsoft was a mobile device management company, and that was a big space in the enterprise mobility world, and had a good exit with that, and then spent 12 years at Microsoft. Actually was involved in more mobile device management products inside Microsoft, as well as the IoT stuff inside Microsoft. It started with our embedded folks, who I used to be tight with back in the Windows Mobile days. And we had, if you remember, Windows CE, and those teams broke apart. The embedded folks ultimately built a product called the Intelligent System Service, which was an early IoT thing. And then it evolved and went into Azure and Azure IT. And so I got to spend time with those folks. So I've been doing this a long time. And you know what? In addition to just knowing the technology and knowing how it works, it's so good to go out and actually talk to customers. You'd be amazed. You find out in life when you actually talk to real people. And so I do that. And you find out what works and what doesn't, and what they want and what they don't want. And you know what? Most people are out there trying to do their job at their company, doing whatever that company does. And I love to say, most companies are not on the technology hamster wheel like we are here in Seattle or down in the Valley. And so make it for those folks. And so that's exactly what I'm doing. And so what's new, aside from making it really easy, I'm really focusing on edge computing, which is the thing. To me, it's the edge is actually the default location. That's where the machines, that's where the things are. A lot of companies who jumped on the IoT bandwagon over the last 5 years, like the hyperscale cloud providers, kind of try to create a narrative where IoT somehow had to include the cloud. And there would be some utopia with trillions of IPv6 devices all streaming to one cloud. Except then you talk to customers who are in buildings like hospitals or factories or refineries and power plants, and they go, yeah, that's not going to happen ever. And it's like, so if you want my business, you're going to have to rethink what you're doing. It needs to be in my four walls. Data's not leaving my factory. And so listen to customers. They'll tell you what they want. And so the edge is the default. It's not new. It's what we've been doing. We've been doing the edge. We used to have mainframes a long time ago. We still do. But what was the revolution that, against the mainframes? It was the PC revolution, right? All of a sudden you had computers on everyone's desks, and it was distributed, and you had local area networks, and all of a sudden you had all this chaos, and it changed the world. That's our default state, and that's where I'm at. So I'll be heavily, because there's reasons for that. Be close to the machines, latency. People want answers to the questions. They're listening. The machines are now talking to us, and we need to listen, and we need to respond in milliseconds. And we can't worry about the fact that maybe the internet's down, or this distant cloud is thousands of miles away, and it's going to take a long time, and it's going to munch on that data and then give me an answer. People need real-time streaming answers quickly. So the edge is where it's at. And then I'd say the other thing I'm really focused on is digital twins.
Talk to us about digital twins. That's an interesting concept.
It is, and it started, kind of in the industrial world, the manufacturing world. Actually, it really started with NASA. I'm sure most people have watched Apollo 13, right? Yeah.
Slide rulers and pencils and trying to calculate entering the orbit.
My kids are like, wow, people were really smart back then, and they didn't have like iPhones. How did they do this? It's amazing. But you'll remember those guys are, they're having some trouble out in space, and luckily you had Gary Sinise down in Houston with a replica of the spaceship trying to figure out how to put square pegs in round holes.
Yes, well, that was a twin, but a physical twin.
It was the physical twin, but after a while, NASA realized we're not always going to have physical twins to troubleshoot or to figure out better way performance and aerodynamics or every kind of thing like that. So they started building high-resolution digital models of the spaceship.
Mm-hmm.
I think they started doing it really in earnest with the space shuttle. We need to have a digital space shuttle, and every last component, every little tiny thing, we need to replicate that digitally. And so they did. And you've probably seen, really fancy 3D CAD models, where you're rotating it around. I remember back in the 90s of my first experience with when Boeing started using CATIA to start digitally designing their aircraft and stuff like that. It was a huge revolution. And that's how everything's done now. So digital representation of a physical object. So I'm a huge fan. And so you can imagine in IoT, we're talking about trillions of physical objects, and we need a digital representation, but not just the simplest version of that. I've been working, I spend a lot of time in factories, and the machines I work with are so complex that you can't think of them as a simple digital twin. Let me make it simple for the audience. Let's just take, instead of saying I have a car and the car's got all these sensor values, you've got to realize that the engine is so complex onto its own that it probably needs to be its own digital twin, and maybe the transmission, right? And other parts. And so it's important to model complex subsystems and then show how they're in a parent-child relationship. The master, the overall digital twin, the parent is the car, and then the engine, and other components. And then they can, as things, you're looking for anomalies, you're applying rules, you might apply advanced analytics to the changes in what's going on in these subsystems, and then know that, sometimes you go, let's talk about like you go to a repair shop and the car guy says, you got a little problem, I'm hearing this weird sound, but you know what, I think you can drive it for another 10,000 miles and you're going to be good. But then other times they go, you know what, this is going to have a causal effect, a cascading effect to these other components, and you're in big trouble. Well, that's the real world. So with IoT, you need to have those complex subsystems, because something happened down here could cause something bad up here, which causes the whole car or your industrial robot to fail.
Yeah, Rob, I remember reading the post-incident report on the Gulf of Mexico oil rig that blew up.
Yeah, Deepwater Horizon.
Injured a lot of people and made an ecological disaster there. The post-incident report said there were 600 sensors screaming at the people, but there was no organization of the data. They didn't know, what that all meant.
Yeah.
There was no instruction that said, when you see this sequence of sensors and this reading, here are the first 3 steps you must take now, and here's the next 3 steps. None of that was there. It was 600 screaming sensors, and it just overwhelmed them. So there was no order to the data. So what I'm hearing from you is that a significant part of the value is actually having ordered data so you can develop meaning around it.
Absolutely. We shouldn't have to depend on people especially in a horrible situation like the Deepwater Horizon. They got explosions, and I've got 600 sensors yelling at me, and I'm trying to put out a fire or something else. So machines, computer systems need to take these actions on our behalf and do these. And sometimes it's just simple things, and sometimes it might take more advanced analytics. And so when these different subsystems, like on a drilling platform out in the Gulf of Mexico, it'll start to notice things are going wrong. And we can't live in a world anymore where there's people staring at a screen waiting to see red lights flashing.
Right.
Or like you think, or in a lighter moment, think of Homer Simpson looking at the nuclear reactor thing, right?
Yes.
We need to handle those. And there's plenty of systems that do handle stuff like that. Well, we need to get serious about that, because there's too many things. The systems people build today are so complex, humans can't wrap their head around all of them. And so we need to take that in consideration. There's no big manual anymore, or people are going to run around and fix all that stuff. So things need to be sustainable and fix themselves. And so I think digital twins is a great way to model what's happening in real time with all these systems and how they interact with each other. Also, on the flip side, people use digital twins to help make better products, because in a digital twin, I'm flowing data, let's say, from the real thing into this digital twin, and triggers are firing and events are firing, and simple scripts, advanced analytics, maybe some kind of machine learning, all kinds of things are kicking off and reacting to that. And then you can put fake data into it. It could be like a windmill, like a turbine, in a windmill farm, and you can fake it out and say, well, you're getting a lot of stress on the wind, and things leaning over, how much can it handle, all these kinds of things. It can help you build better products, because you can just start flowing fake data. Simulations is the big thing. I want to simulate extreme situations, right? I'll do that through the digital twin, and the digital twin is going to break or fail, and it's going to tell me where it's failing, and then I go, great, now we're going to go back to the drawing board and make a better actual real product.
Wow. I imagine having new kinds of data being fed in also gives you the opportunity to rethink business models and processes for improvement.
Absolutely. There's this whole, I know, gosh, it's like a drinking game saying digital transformation, but but yes, how do we, what are business and things doing around digital? That's nothing new. But the first thing we did was we digitized things. There's digitization, there's digitalization, and then saying, because we start off by taking a manual process. Some guy goes somewhere and he writes down on a clipboard, whatever, and then we turn that into a digital process, and it made it more efficient. We get better and better. But now we need to, could I rethink the whole way that's done now that I'm fully digital? And IoT is the backbone of this stuff. Other stuff we talked about earlier. You and I came from the mobile space.
Yep.
Whether it's devices, wireless telecom, data networks, device management, mobile enterprise application platforms. Those things where I got to connect to a lot of back-end systems. I need to flow data to any device to empower my workforce. And we have had this mobile revolution, and it's been amazing. Well, I don't think IoT should be siloed from mobile. And so you'll see us build, the technology will build, it will not discriminate against people. I like to say I'm building the internet of humans and machines. And so machines will be sending telemetry, people will send telemetry, but they'll use a smartphone or a tablet or a PC, or they'll have the glasses on, or it'll be a medical sensor on their behalf. And that bidirectional flow and going into back-end systems,
you gave us the example earlier about a hospital environment where the individual, the human in the room, is full of sensors, so it can be connected. And that reminds me that when at the World Economic Forum, when they started talking about the fourth industrial revolution there a couple of years ago, they were saying it's the convergence of biological and digital systems. And so when you brought that up earlier, I went, there it is.
There it is. I'm a huge fan of helping people and healthcare. And so this system that we're working on is going to do that. So that same concept of digital twins to help out Gary Sinise and Tom Hanks, or to help out a factory or the Deepwater Rising, why can't it be people too? So you can imagine a patient in a hospital being a digital twin of that person. And what are the subsystems a human has? They got a heart, they've got a brain.
Right.
Super complex systems with thousands, who knows how many data points coming off of those things, right? And so we need to treat them as being special, separate things, but they all roll up to one person. And so, but people don't just shoot that data from their fingertips.
Right.
Machines are sending that on the behalf of the person. So the person's the digital twin, and then the ECG, pulse ox, all kinds of things. If you can imagine a poor person sitting there in a hospital bed, it's doing it on behalf of the person. The person's the digital twin. The machines, they may be twins themselves, but they're gonna, in my system that we're building, they'll be able to, certain machines will have rights to send data on behalf of humans. And we'll do that. And so you can imagine as you go through edge systems and maybe to other parts of the system, you'll see the digital twin for the human, and then you can imagine a visualization of that person with every part of their body alive with all that living telemetry data.
Wow. This is cool. So powerful. Well, Rob, I am so excited to see how this develops with your new company, Enterprise IoT. And thanks for bearing with me and doing 2 interviews in one day.